The universe is incomprehensibly large and we've barely looked. What if everything humanity has ever explored, every ocean mapped, every mountain climbed, every star catalogued, amounts to less than a single grain of sand on an infinite beach, and we have the audacity to conclude that beach is empty? The observable universe contains an estimated 2 trillion galaxies. Each galaxy holds hundreds of billions of stars. Each star potentially hosts planets. The numbers are so catastrophically large that the human brain genuinely cannot process them. We just say trillion and move on as if we understood it. But here is the shocking part. We have only meaningfully searched for signals from a microscopic fraction of our own galaxy, not the universe, our neighborhood. Concluding we are alone, based on current searches, is like dipping a teacup into the Pacific Ocean, finding no fish, and declaring the ocean lifeless. The universe is not hiding intelligence from us. We simply haven't looked. And the difference between those two statements should keep every scientist and every curious human being permanently awake at night. The chemistry of life is embarrassingly common. What if life isn't a miraculous exception written into the universe, but rather an almost inevitable consequence of chemistry? And the universe has been running that experiment on billions of planets for billions of years before Earth even existed. The building blocks of life, amino acids, carbon compounds, water molecules, organic chemistry, have been detected in meteorites, in interstellar clouds, in the atmospheres of distant worlds. In 2022, scientists detected complex organic molecules in star-forming regions light years away. Life on Earth appeared remarkably fast after conditions became suitable, geologically speaking, almost immediately. That is not the behavior of an unlikely accident. That is the behavior of a process, looking for permission to begin. If the chemistry runs itself everywhere the conditions allow, and those conditions exist on potentially billions of worlds, then the question is no longer could life exist elsewhere. The real, terrifying, magnificent question becomes, why haven't we heard from it yet? And that silence is the most interesting scientific mystery in all of human history. The Fermi paradox, the silence that should terrify you. What if the most chilling evidence for alien intelligence isn't a signal we receive, but the deafening, inexplicable, universe-wide silence we cannot explain? This is the Fermi paradox, and it is brutally simple. The universe is ancient, vast, and chemically primed for life. If even a fraction of civilizations develop interstellar travel or communication, the galaxy should be buzzing with signals. Given enough time, a single civilization expanding at even 1% the speed of light could colonize the entire Milky Way in a few million years, a cosmic blink, yet we hear nothing. We detect nothing. We find no megastructures, no signals, no evidence of engineering on astronomical scales. This silence has exactly 3 possible explanations, and every single one of them is more disturbing than the last. Either intelligent life is almost impossibly rare, or something destroys civilizations before they can reach out, or they are here, and we are simply not capable of recognizing them. Which answer do you find most comforting? Because I find none of them comfortable at all. Intelligence itself may look nothing like us. What if we've been searching for the wrong thing entirely? Broadcasting radio waves into space, listening for voices, looking for humanoid beings, while intelligence in the universe has evolved into forms so radically different from us that we would not recognize it as life, let alone intelligence, even if it was directly in front of us. On Earth alone, intelligence evolved independently in mammals, birds, cephalopods, octopuses, solve puzzles, navigate mazes, use tools, and their nervous system is so alien that over 60% of their neurons are in their arms, not their brain. And that's on one planet, across billions of worlds, with different gravities, different chemistries, different evolutionary pressures over billions of years. Intelligence could be distributed, crystalline, electromagnetic, collective, or exist on timescales so vast that our entire civilization flickers like a camera flash from their perspective. We keep broadcasting, hello, we're here. But what if the universe's intelligent life looks at us the way we look at an anthill, not with hostility, but with the quiet recognition that meaningful communication simply hasn't become possible yet? The great filter. Are we before it or after it? What if the reason the universe appears empty is because there is a catastrophic barrier, a great filter, that almost no civilization ever survives? And the most terrifying possibility science has ever produced is that we haven't reached it yet. The great filter theory suggests that somewhere along the path from simple chemistry to galaxy-spanning civilization, there is a step so difficult, so improbable, or so dangerous that virtually no species clears it. The hopeful interpretation is that the filter is behind us, that the emergence of complex life, or eukaryotic cells, or sexual reproduction was the near impossible step, and we are among the extraordinary few who made it through. But the terrifying interpretation, the one that should make every person on this planet reconsider our priorities immediately, is that the filter is ahead of us. That nuclear weapons, climate collapse, engineered pandemics, or technologies we haven't yet invented represent a wall that ends civilizations at approximately our current stage of development. The fact that we find no ruins, no remnants, no ancient signals from dead civilizations, that is not reassuring. That is the universe whispering something we desperately need to hear. Our own existence is the most extraordinary clue we have. What if the most profound scientific data point about life in the universe isn't a radio signal from a distant star, but the simple, staggering, almost incomprehensible fact that you exist right now, consciously reading these words? Consciousness, the ability of matter to become aware of itself, is the most unexplained phenomenon in all of science. We do not know how it arises. We cannot measure it from the outside. We cannot build it from scratch. Yet here it is, in you, in me, in billions of humans, and in varying degrees across the animal kingdom. The universe has organized itself in at least one place into structures capable of wondering about the universe. That is not a small thing. That is extraordinary beyond calculation. And if it happened here, on a medium-sized planet, orbiting an average star, in an unremarkable corner of one galaxy among 2 trillion, the mathematics of probability do not allow us to call it unique. The universe is not just a place where life can exist. It may be a place where life is trying to understand itself, everywhere all at once in ways we haven't imagined. What if, and I want you to sit with this question, really sit with it, because it is the most important question our species has ever asked. What if we are not alone? Now I know what happens when people hear that question. Half the room starts thinking about movies, the other half gets uncomfortable, and a small, wonderful fraction, the fraction I want to talk to today, starts thinking about mathematics. Let me tell you something about the universe that I find so astonishing, so absurdly, almost offensively large, that every time I try to fully appreciate it, some circuit in my brain quietly gives up. There are approximately 2 trillion galaxies in the observable universe. 2 trillion, each one containing hundreds of billions of stars. Many of those stars with planets, many of those planets sitting at distances from their stars where liquid water, the universal solvent of biochemistry, can exist on the surface. Now, given those numbers, and I want you to feel the weight of those numbers, not just hear them, given those numbers, what is the intellectually honest answer to the question, are we alone? I'll tell you what it isn't. It isn't certainty in either direction. And anyone who gives you certainty in either direction is not doing science. They are doing something else entirely. Here is what is scientifically honest. We have searched an almost laughably small portion of one galaxy. We have pointed radio telescopes at a few thousand stars. We have sent 2 pieces of metal, Voyager 1 and Voyager 2, crawling into a cosmos so vast that they will not reach even the nearest star system for another 70,000 years. And from this, some people conclude, we are alone. I find that conclusion breathtaking in its overconfidence. Now let's talk about chemistry, because chemistry is where this gets genuinely exciting. The building blocks of life are not rare. They are everywhere. Amino acids in meteorites. Complex organic molecules detected in interstellar clouds light years from any planet. Water ice on moons, on asteroids, potentially beneath the frozen surface of Europa right now as you read this. The universe is not reluctant to build the components of life. It manufactures them in the cores of stars and scatters them across space when those stars explode. And on Earth, life appeared almost immediately after conditions allowed it. 4.5 billion years ago, this planet was a molten catastrophe. A mere few 100 million years later, geologically instantaneous. Life was already here. Not waiting, not struggling to begin, already here. That is not how extremely unlikely accidents behave. That is how processes behave when conditions are right and chemistry is doing what chemistry does. Which brings us to the question that I personally find the most intellectually disturbing puzzle in all of human science. If life is common, if chemistry cooperates, if billions of planets have had billions of years to run the evolutionary experiment, then where is everybody? This is not a casual question. This is the Fermi paradox, and it deserves your full, uncomfortable attention. A civilization that develops even modest interstellar travel capability, expanding at 1% the speed of light, could colonize every star system in the Milky Way in a few million years. The Milky Way is over 10 billion years old. Even if spacefaring civilizations are rare, 1 per million years of galaxy history, there should have been thousands of them before us. And yet, silence. No signals, no megastructures, no evidence of engineering on astronomical scales, no ancient ruins on the moon, no signals carved into the cosmic background radiation, nothing. Now I want to tell you something about that silence, because it is not nothing. Silence in science is data, and this particular silence points toward 3 possible explanations, every one of which is more unsettling than the last. First possibility, intelligent life is almost impossibly rare. The chain of events that produced a species capable of asking this question, the right star, the right planet, the right moon stabilizing axial tilt, the right asteroid impact eliminating the right competitors, the right evolutionary pressures, is so extraordinarily specific that it may have happened once. Here, just us. Second possibility, civilizations reliably destroy themselves before they can reach the stars. Technology outpaces wisdom. Nuclear weapons, engineered biology, climate catastrophe, some wall exists, and nearly everyone hits it. The galaxy is not silent because it is empty. It is silent because it is full of graves. Third possibility, and this one I find the most philosophically staggering, they are out there and we simply cannot perceive them. Intelligence that has had 1 billion years longer than us to develop may operate on physical, temporal, or dimensional scales so foreign to our experience that we would not recognize it as intelligence any more than a bacterium recognizes a symphony. Now here is where I want to challenge something fundamental about how we think about this search. We have been almost exclusively searching for us. We broadcast radio waves because we use radio waves. We look for planets like Earth because we live on Earth. We search for carbon-based chemistry because we are carbon-based. And there is a certain understandable logic to that. But consider, on this one planet, in this one corner of one galaxy, intelligence evolved independently in creatures with completely different nervous systems. An octopus has neurons distributed throughout its arms. A crow solves multi-step logical problems with a brain the size of a walnut. A slime mold, which has no brain, no neurons, no nervous system of any kind, navigates mazes and finds optimal paths. If intelligence is this structurally diverse on a single planet, what does intelligence look like across 2 trillion galaxies with billions of years of independent evolution? We might be looking for a radio signal while the answer is encoded in the large-scale structure of space-time itself. And then there is the great filter. The theory, first formalized by economist Robin Hanson, that somewhere between simple chemistry and galactic civilization, there exists a barrier so catastrophic that virtually no species crosses it. And the question that should change how every government on Earth prioritizes its resources, are we before it or after it? If the filter is behind us, if the near impossibility was the emergence of complex cells or multicellular life or sexual reproduction, then we are the lucky ones. We made it through. The galaxy may be full of planets with microbial life, and we are the extraordinary exception that crossed into complexity. But if the filter is ahead of us, if species at precisely our technological level reliably destroy themselves with the very tools they celebrate as progress, then the silence of the universe is not empty space. It is a warning, written in the absence of signals from civilizations that thought they were going to make it. I want to leave you with something that I think about more than anything else when I consider this question. You exist right now, consciously aware that you exist, capable of asking why you exist and whether others like you exist elsewhere in the cosmos. You are matter that has organized itself over billions of years of stellar and biological evolution into a structure capable of wondering about the universe that produced it. That is, objectively, the most astonishing thing that has ever happened, as far as we know. And if it happened here, on this ordinary planet, around this average star, in this unremarkable galactic suburb, then the question is not whether it happened elsewhere. The question is why we are not yet talking. And the answer to that question, when we finally find it, will be the most important thing our species has ever learned. We began with a question so large it makes most people uncomfortable. Are we alone? And we have not answered it, because the honest scientific truth is that we cannot yet answer it. But we have done something more valuable than answer it. We have understood why it matters. We have seen that the size of the universe makes solitude implausible. We have seen that chemistry cooperates with life enthusiastically. We have stared into the Fermi paradox and refused to look away. We have considered that intelligence may be unrecognizable. We have faced the great filter without flinching, and we have recognized that consciousness itself, yours, right now, is the universe's most astonishing known experiment. The search continues. It must continue, because the alternative, deciding we already know the answer, is the one thing a genuinely curious mind should never do. Keep asking, keep searching, keep being uncomfortable with silence. That discomfort, that is science working exactly as it should.